So we're still in 5.3 in internal energy. Let's look at a simple example. Here we've got two carts again, they're colliding. We've got a cart 2 going at half a meter per second and cart 1 at 0. And after collision, cart 2 goes at 0.2, but we don't know what cart 1's final velocity is. We do have the inertias of both. 0.2 cart 1, so that's 0.2 kilograms there. And let's see. Cart 1, no, I'm sorry. It said cart, okay, they're identical. Okay, so they're both cart 0.2. Now, the question is the collision elastic, inelastic, or totally inelastic? What do you need to do to find out if it's elastic or inelastic or totally inelastic? You need to find the relative speed afterwards. You need to look at the relative speed before, initial, and you need to find the relative speed afterwards. So how are we going to do that if we do not have our final speed, velocity of 1? Well, remember in any collision, any interaction, we've got the conservation of momentum. If it's elastic, if it's inelastic, if it's totally inelastic, momentum, in an isolated system, momentum is conserved for any type of interaction. So we can use our conservation of momentum to calculate our final velocity. Okay? So that's our initial momentum and that's our final momentum. So we use conservation of momentum. I'm not going to go through this. You know exactly how to do it. To find our final velocity of 1. Now that we have our final velocity of 1, we calculate our initial relative speed. We calculate our final relative speed. And we see what? What do we see? You answer me. We see that these are not the same. So because our final and initial relative speeds are not the same, we have an inelastic collision. Okay? So there is the answer to part A. By what amount does the internal energy of the two-cart system change? So if you want to find the amount of internal energy change, what do you need to do? You need to find how much the kinetic energy has changed. Remember that delta K equals the negative of delta E internal. Remember, the total energy is equal to K plus E internal. Okay? So the total energy is equal to this. So if we want to find out what how much internal energy has changed, we need to find how much the kinetic energy has changed. So we calculate the kinetic energy, the initial kinetic energy, which is just half mv squared of this plus half mv squared of this before collision, and we have that. Then we calculate half mv squared plus half mv squared after collision, and we get this. And we see, what is K final minus K initial? K final minus K initial is minus 0.012 kilogram meter squared per second squared, or joules, right? Why don't they say joules? Okay. Now, so we know that the E internal is the same magnitude but the opposite sign. So if my kinetic energy has gone down by that amount, my internal energy has increased by that amount. Okay? All right, so that's good enough. Okay, see you in the next one.